Let's do another statement. If you have equal amounts of carbon dioxide gas and methane gas in the atmosphere, then the carbon dioxide gas will have just as much impact on the global climate as the methane gas. True or false? False. This is an example of a non sequitur. Here's another one. John is from Baltimore, so no one should listen to what he has to say about music from New Orleans. In the same way that John might know something about New Orleans music, even though he's from Baltimore, if carbon dioxide and methane had equal amounts in the atmosphere, they wouldn't have to have the same effect on the climate. So let's look at the effects that they do have. Not all gases in the atmosphere insulate in the same way. Think of the difference between wearing winter and summer clothes. Winter clothes trap more heat than summer clothes do. Greenhouse gases in the atmosphere are similar to clothes in that some gases are more effective at insulating than other gases. In particular, methane has a very effective insulating property, meaning that small amounts of methane can insulate much more effectively than similar amounts of carbon dioxide, which is less effective. In short, it takes less methane compared to carbon dioxide to trap the same amount of energy. So methane is more like winter clothes, while carbon dioxide is more like summer attire. We have a way of quantifying this called the global warming potential, which was developed to allow comparisons of the global warming impacts of different gases. Specifically, it's a measure of how much energy the emissions of 1 ton of a gas will absorb over a global period of time relative to the emissions of 1 ton of carbon dioxide. So basically, we're setting carbon dioxide to 1, and when we look at that global warming potential, we see that methane is 25 times more powerful than carbon dioxide, and there are other greenhouse gases, like nitrous oxide, that are even more powerful. These global warming potentials provide a common unit of measure which allows us to add up emissions estimates of different gases, for example, making a national greenhouse gas inventory, and allows policymakers to compare emissions reduction opportunities across different sectors and different gases. When we want to know about the relative effects of different greenhouse gases in terms of their effects on climate, three things matter. We've already talked about the global warming potential, or how good they are at trapping heat. The second is how long the gas lasts in the atmosphere before it gets taken up by plants or ocean or chemically turned into something else. And here we see the carbon dioxide has a really long lifetime in the atmosphere relative to methane. The final thing that matters is the amount. Simply put, the world emits a lot more carbon dioxide than it does methane and the other greenhouse gases. It's not that the other greenhouse gases are unimportant. It's just that it's helpful to frame things in terms of the biggest source of greenhouse gases, the atmosphere. And when we look at concentrations of greenhouse gases in the atmosphere, we see a couple of things on this slide. The first thing that you should notice is that the greenhouse gas concentrations were relatively stable for hundreds to thousands of years before the Industrial Revolution, and that after the Industrial Revolution, we see a rapid increase in all of the different greenhouse gas concentrations. But the second thing you should notice on the slide are these y-axis titles. Our carbon dioxide red line is shown in ppm, or parts per million. So this graph is a little out of date. We're now above 400 parts per million carbon dioxide in the atmosphere. Our nitrous oxides and our methane are both shown in parts per billion. So there is 1,000 times less nitrous oxide than there is carbon dioxide on this graph, and there is about 100 times less methane um, than there is carbon dioxide on this graph. So for these reasons, we tend to focus our discussions around carbon dioxide, not to ignore the other things, and not because they behave the same way in the atmosphere, but because it allows us to focus and even sometimes to express all of our data in units of carbon dioxide equivalents and kind of simplify the discussions.